In this video, I'm going to talk about style versus syntax, and we'll eventually get to this activity, erroneous code. You may or may not like this, involving TempConverter. This will be available online via Canvas or CTLS. Programming style refers to the stylistic guidelines that programmers follow when writing source code. Things like proper indentation, camel casing, which we learned about in a previous video, and beginning the class name with an uppercase letter. These are all examples of style. So when I talked about camel casing, that was back with user-defined symbols. And I also in there talked about these stylistic guidelines just a little bit. Now, in practice, there's kind of two sets of stylistic guidelines per programming language. There tends to be stylistic guidelines that the programming language follows, right? People that write in Java almost always use camel casing. They don't have to, but they almost always, right? People that write in Python maybe don't use camel casing. Maybe they use underscores to separate their words, right? That is a stylistic decision that is generally kind of paired with the programming language. In practice, if you were to get a job programming, your organization, right? I'm talking the business you work for, or the nonprofit organization. Those would give you stylistic guidelines that they expect. For example, I know for a fact you can literally Google it, but Google has their own set of stylistic guidelines. They say if you're going to write code for us here at Google in Java, these are what we expect. Things like end of line brace, for instance, right? That's one that's like 50-50. Most people that code in Java, they're going to use camel casing. But end of line brace versus next line brace, let me show you what I'm talking about. Right here I'm using next line brace, but end of line brace is also acceptable. Right? This one's up in the air across the entire programming community. Lots of people use this. I like to think it's 50-50, but it's actually probably a majority of programmers in industry actually use end of line brace. I think the Google stylistic guidelines say to use end of line brace as opposed to next line. I use next line because in the academic world, you tend to see it there as opposed to the industry world where we tend to see end of line. So, what am I saying? These are all stylistic decisions, right? There's some variance in there. They tend to be programming language dependent or organization dependent. Additionally, when we're talking about style, consistency is important, right? Here I have two very inconsistent statements. Well, I say very. I got spaces here on either side of this equal sign, but not here. I would say that this is not consistent, and you really should be. It's to your benefit, actually. If you have good programming style, it can help reduce errors and increase readability. If you're consistent across all of your source code with how you do your spacing when it comes to operators, it becomes easy to identify mistakes. Things like maybe you forgot to put an operator or you forgot a semicolon, right? Because of good style. My eye I can't get over this. My eye gravitates to this because it's so inconsistent for what I'm used to seeing in my own source code. And the same is going to happen with you. If you develop good style, you can quickly find errors because the style is not what you're used to seeing. However, style is not necessary from a compiler standpoint. Compilers care a great deal about syntax. Syntax refers to the strict rules that define how letters, numbers, and symbols can be combined to generate code. It is not very forgiving and is the only thing compilers truly care about. For this reason, errors related to syntax are often called compile time errors. So I need to talk about compilers because this is kind of the first time that we're seeing it. We write code in Java. It is a high-level language. Other high-level languages you've heard of, C++, Python, C, right? Those are all high-level languages. They are written in something that we humans can interpret. Effectively, Java's in English. There's like 50 reserved words, right? And those are the only English words you need to know, but it's still English. It's still written in a high-level language. What the computer needs in order to actually execute your code is binary, zeros and ones. Okay? So what a compiler does effectively is take that high-level language, the Java, and it translates it down into zeros and ones so that the computer can actually execute your commands. That is what a compiler is, right? It's the translator that takes it from Java to ones and zeros effectively. Okay, if a program is not free of syntax errors, right? If you got syntax issues, it won't compile, it won't translate. Examples of these include extra semicolons or missing semicolons, assigning incompatible data types. Here we're talking about things like trying to save a double into an integer. That's an incompatible data type. Trying to save an integer into a string. That's an incompatible data type. Referencing a variable that does not exist. Maybe you're trying to refer to x and you never even made x. Accessing a variable with no value. Maybe you're trying to print x or use x in some type of equation, but you declared it, right? You said integer x, but you didn't assign it a value. You didn't initialize it. Class name does not match the file name. Okay, let's talk about these for a moment. I'll bring up IntelliJ, right? A syntax error, right? Missing semicolon. We see right away IntelliJ is a great IDE, and it underscores that, or like it highlights it with red, underlines it. It's trying to indicate that there's something wrong here. Anytime you see a red squiggly boy, that is a syntax issue. That is a compile time issue. This program won't even compile. Now, technically, when you hit this little run button in IntelliJ, it is going to compile it and run it. Those are technically two different steps. And in some IDEs, you actually have to go through the process, meaning it's 2 button clicks. You have to tell it to compile before you run. Both are happening for us. It is compiling and it is running. But if I have a compile issue, I'm going to stop my program and then I'm going to try to run it, and you're going to see that it won't even get past the compile stage. Right? We need a semicolon here. Other issues include, other compile time errors include trying to reference a variable that doesn't exist. Maybe instead of input, I'm trying to reference KB. Right? This is red. This is a compile time issue. This is a syntax issue. KB doesn't exist. I didn't make that anywhere. The only scanner that I possibly have is input. Right? Lowercase s on scanner. That's an example of a compile time issue. Why? Because this doesn't exist. There's no such thing as scanner with a lowercase s. So these are all examples of compile time or syntax errors. Those words are interchangeable. And they're pretty much anything that IntelliJ highlights in red or tries to underline with red. Okay, that's what the compiler cares about. That is different from style. That's different from logic or runtime errors. A program will still compile if logic errors exist. Okay, examples of these include incorrect calculation due to int truncation, right? We've encountered this. We actually saw it a couple of different times where we did things like 4 divided by 3 and truncation occurred. Our program compiled, our program ran, IntelliJ didn't highlight anything with red. So this was a logic issue for us, right? A math issue. Dividing by 0. Let's see if we can demonstrate that one. Real fast, I'm just going to, very first line of my program, plug in a system.out.println line with an S out. And what we're going to do is, what did I say, divide by 0? Sure, 3 divided by 0. This is not red, right? There is actually no red in my program. This will compile. And whenever I actually go to run it, that's the point at which the error is detected, right? Syntactically, dividing an integer by an integer makes sense. There's nothing wrong with that, right? But here we see an exception, right? Division by 0. My program ultimately crashed, but because of some logic error, not because of a syntax or compile time error. Input mismatch exception, right? This is actually one that occurs. Most people don't quite know what that is right away. I'll show you what it is. Okay, I'm running my, what is this, compound interest program. First thing it's asking me for is the principal amount, which as we see right here, should be a double. I'm going to enter hello world. That is an input mismatch exception. I am looking for a double, and what I got was a string. Now, what I'd like you to notice is My program was running. This is not a syntax error. The program compiled. It happened, the issue happened at runtime whenever we were executing the program. Okay? Accessing an index does not exist. That one I can't really demonstrate for you just yet, but we'll see more about that later. So I've already demoed those a little bit, and that's actually going to be the end of our slides here. I just want to highlight this, right? Those errors that I just showed you there towards the end, they occurred at runtime, hence this name. They're logic errors that occurred at runtime. They're the opposite of compile time errors. That's going to be it for this one. I'll see you in the next one.